The next chapter in our chemistry is acids, bases and salts. So you have learnt in your previous classes that sour and bitter tastes of food are due to acids and bases. So acids are having sour taste and bases are having bitter taste. So, if someone in the family is suffering from a problem of acidity after overeating, so if someone is suffering from acid problem in their stomach after eating so much of food or any other problem because of acidity, then we will suggest a lemon juice or vinegar or baking soda, which we will suggest. So, lemon juice is acid, it will be having citric acid. So, already acidity, okay. Can we give again acid? Then vinegar or baking soda? Yes, it is a base. So when we have acidity or acid in our stomach, more acid is present in our stomach, then we should give base so that it will be neutralized in our stomach and our problem will be reduced. So which property did you think of while choosing the remedy? What property we used? Because if acid is there, we have to use base. So that what happens? It will get neutralized. Surely you must have used knowledge about the ability of acids and bases to nullify each other's effect. Yes, no? We discussed that only, that the acids and bases, when they react with each other, they nullify each other's effect, that is they neutralize each other. So we tested sour and bitter substances without tasting them. So how we can tell? By seeing the acid and bases, they have sour taste and bitter taste. Did we really tested it? No. So you know that acids are sour in taste and they change the color of blue litmus to red. So they will convert blue litmus paper to red, whereas bases are bitter in taste and will they change the color of red litmus to blue. So what is this litmus? When we see, litmus is a natural indicator, so it will indicate whether it is an acid or base. And turmeric is also one natural indicator we can use. When we see, when any stain of curry on a white cloth becomes reddish brown when soap, which is basic in nature, is scrubbed on it. So we are eating something, some curry spilled on our white dress, so it will be in yellowish in color. Yes, no? When we rub it with the soap, it will become reddish in color. So because it is in basic in nature, so as yellow is a indicator, it will change its color. So again, when we wash it with water, so what happens? It again turns into yellow when the cloth is washed with plenty of water. So you can also use some synthetic indicators. So these are all natural indicators like turmeric, litmus. We can use even man-made or synthetic indicators such as methyl orange phenolphthalein for the test of acids and bases. To test whether it is an acid or a base, we can use this. So we will, in this chapter, what we are going to study? We study the reactions of acids and bases. How the acids or bases react with each other or react with any other things, or how acids and bases cancel out each other's effect, and many interesting facts about this in our day-to-day life. So I already told what is a litmus. It is a natural indicator. So litmus solution we can prepare. It is a purple dye. Which color dye? Purple color dye, so which is extracted from a lichen, a plant belonging to the division Thallophyta, and this is commonly used as an indicator when the litmus solution is neither acidic nor basic. So whatever is the solution we are taking, it is not acid or it is not base, then it will remain in its natural color like purple. There are many other natural materials like red cabbage leaves, turmeric, colored petals of some flowers such as hydrangea, petunia, geranium, which indicate the presence of acid or base in a solution. So in simple, we can call all these as indicators or acid-base indicators. So next, how to understand the chemical properties of acids and bases? We can understand the chemical properties of acids and bases by some activity. Let's see the activity acid bases in the laboratory. So when we see the acids and bases in a laboratory, so what we have to do, collect the following solutions from the science laboratory. We can collect like hydrochloric acid, sulfuric acid, nitric acid, acetic acid, sodium hydroxide, calcium hydroxide, potassium hydroxide, magnesium hydroxide, ammonium hydroxide, etc. Then all these we put one drop on watch glass and one by one and test with a drop of indicator. So we have to test one by one, putting in a watch glass by means of an indicator. What change in color do you observe with red litmus blue, phenolphthalein, methyl orange for each of the solutions? We know that all the acids will be changed to blue litmus to red, and all the bases red to blue. Depending on that, we can find out whether it is an acid or base. From this, hydrochloric, it is an acid. Here the name itself is acid, so it will be converted blue litmus to red, blue litmus to red, blue litmus to red, blue litmus to red. And sodium hydroxide, it is a base, so red litmus to blue, red litmus to blue, red litmus to blue, red litmus to blue, and red litmus. So all these are bases. So this indicators will tell us whether a solution is acidic or basic, or by change in their color. So there are some substances whose odor changes. Odor means smell. Changes when acidic or basic media, in the presence of acidic or basic media, their smell will be changed. These are called olfactory indicators. So for example, onions. So take some fine chopped onions in a plastic bag along with some strips of clean cloth. We have to put some strips of clean cloth along with that chopped onions. Tie that, and one night you leave it in the fridge. The cloth strips can now become, we can use it for acids and bases to test. So take 2 of these cloth strips and check their odor. If you check their smell, keep them on a clean surface and put a few drops of dilute HCl solution on one strip, that is acid in one strip, and base on the other strips, NaOH solution on the other. Rinse both strips with water and again check their odor. Then we will see when they are kept in acid, their odor changes, and when it is again cleaned, again it will be changing its odor. So note your observations. Now take some dilute vanilla essence, so and clove oil, and check their odor. Again the same like that. Take some dilute HCl solution in one test tube and dilute NaOH solution in another. We have to add few drops of vanilla essence to both the test tubes and shake well. Check the smell once again. So from this we can say in the acid it will be having a different smell, and in the base it will be having a different smell. So testing the change in the odor of clove oil with dilute HCl and dilute NaOH solutions, we have to record it. The observations what we see. From this we can say like vanilla, onion, clove, these are all used as olfactory indicators by our observations, because their odor will be changed when they react with acids or bases. So these are about indicators. Like this we can see their properties. So when acids and bases react with metals, what happens? So for this the activity needs teacher's assistance, because it should be carried out carefully. So take about 5 ml of dilute sulfuric acid. So take about 5 ml of dilute sulfuric acid in a test tube and add few pieces of zinc granules to it. What do you observe on the surface of zinc granules? Pass the gas. So what we'll observe? Some bubbles will be coming outside. That is nothing but hydrogen gas. To confirm the hydrogen gas, we can make one test. So that pass the gas being evolved through the soap solution. So we have to pass the gas which is evolved through the delivery tube into the soap solution. We can see soap bubbles filled with hydrogen. Then why are bubbles formed in the solution? Because we will see. So bubbles filled with hydrogen gas. So when we take a burning candle near a gas filled bubble, we will observe burning of hydrogen gas with a pop sound. So here we will get a pop sound. We can do this activity. Instead of sulfuric acid, we can take hydrochloric acid, nitric acid, acetic acid, etc. So are the observations in all the cases same or different? Yes, so because of all or the acids, the hydrogen gas will be released. So reaction of zinc granules with the dilute sulfuric acid and hydrogen gas is released by burning. So what is the reaction here happening? So what is a metal here? Zinc. So Zn plus sulfuric acid H2SO4. So Zn plus sulfuric acid gives they didn't give the equation. Zn, the zinc granules reacts with sulfuric acid to form zinc sulfate and hydrogen gas is released. So the metal in the above reaction will displace hydrogen atom from the acid. So from the acid, this metal will displace the hydrogen atom and forms a compound called zinc sulfate, that is nothing but salt. So the reaction of metal with an acid can be generally we can say when we react a acid with a metal, we will get salt plus hydrogen gas released. So this is the general equation with the reaction of acid with metal. So what happens when a zinc metal is kept in base? Let's see. So again one more activity, same like before. Place a few pieces of granulated zinc metal in a test tube and add 2 ml of sodium hydroxide solution and warm the contents. Here warming is necessary to make the reaction reaction go on. So repeat the steps as same, and we can see hydrogen gas is released here also. We can test the reaction, but this hydrogen formation will not be possible with all the metals. So here the zinc will react with sodium hydroxide to form sodium zincate, which is a salt, and hydrogen gas is released. So like this we can say the action of metals with acids and bases. How do metal carbonates and metal hydrogen carbonates react with acids? So the reaction of metal carbonates and metal hydrogen carbonates, we can say metal bicarbonates react with acids. So we have to take 2 test tubes and label them as A and B. So take about 0.5 gram of sodium carbonate. So in this we should take 0.5 grams of sodium carbonate in test tube A and 0.5 gram of sodium bicarbonate, that is sodium hydrogen carbonate in test tube B. Then add about 2 ml of hydrochloric acid to it. So we will see what we will observe. We will observe so some gas will be released in this. So pass the gas produced in each case through lime water. So when we pass it with the lime water like calcium hydroxide solution and observe, so what we can see? So what is the reaction behind it? When we see the sodium carbonate reacts with hydrochloric acid to form sodium chloride plus water plus carbon dioxide gas is released. So what gas is produced here? Carbon dioxide gas. When metal react with acids, we got hydrogen gas. So when sodium carbonate or sodium bicarbonate reacts, we got carbon dioxide gas. So sodium bicarbonate reacts with hydrochloric acid to form NaCl plus water plus CO2 gas. Carbon dioxide gas is evolved. We have to test the gas whether it is carbon dioxide or not. For this, what we have to do? We have to send this carbon dioxide gas through delivery tube into the test tube containing calcium hydroxide to get calcium carbonate. That is nothing but a white precipitate will be formed. From this we can say when it turns calcium hydroxide, when it turns into milky white color, so we can say that calcium carbonate is formed. That is nothing but white precipitate. So on passing carbon dioxide, the following reaction takes place. So what happens when we pass more carbon dioxide? Actually, calcium carbonate white precipitate is already formed. Along with that, water is there in this reaction. So calcium hydroxide plus CO2 gives calcium carbonate plus water. When we are again sending carbon dioxide to that excess of carbon dioxide, so these two reacts with carbon dioxide and again to form calcium bicarbonate, which is soluble in water. So it is used in the formation of limestone, chalk, marble are the different forms of this calcium carbonate. So all the metal carbonates and hydrogen carbonates react with acids to form corresponding salts, water and carbon dioxide will be released. The generalized equation we can give like metal carbonates reacts with metal hydrogen carbonates to give reacts with acid to give salt, carbon dioxide and water. Carbon dioxide is tested. We know that we can test the carbon dioxide by using calcium hydroxide, that is nothing but lime water. Then how acids and bases react with each other. We know that acids and bases, when we react it with each other, they will nullify their effect or neutralize each other. We can test this. So take about 2 ml of dilute NaOH solution in a test tube and 2 drops of phenolphthalein solution indicated we have to add to it. So we can see the color of the solution, and when we add HCl to the above solution drop by drop, its color changes. So what is its color? Phenolphthalein change after the addition of acid. We know that in the base it will be pink color. When we add acid to it, it loses its color and it will become colorless. So again when it becomes colorless, we can say it is neutralized. So when we add a few drops of again NaOH, again the pink color of phenolphthalein again reappears. So what do you think has happened? We have observed that effect of base is nullified by an acid. So acid's effect will be nullified, means made zero by an acid, or effect of base may be made zero by acid. So this process of reaction is called neutralization reaction, and we can write the equation like this. Sodium hydroxide we took, hydrochloric acid we took, we get NaCl plus H2O. So the reaction between acid and base to give salt and water is known as neutralization reactions. In generally we can write neutralization reactions as base plus acid gives salt plus water. Then when metallic oxides react with acids, what happens? So for example, copper oxide in a beaker we can take, and sulfuric acid slowly while stirring if we continue to do. So we can note the color of the solution. What happens to the copper oxide? The color of the solution becomes blue green and the copper oxide dissolves. The blue green solution we observed is because of the formation of copper chloride. So generally we can write metal oxide plus acid gives salt plus water. So we can write and balance the equation for the above reaction. What is that reaction? We can write. So what is that reaction? That is nothing but copper oxide, metallic oxide reacts with hydrochloric acid to form copper chloride, which appears in blue-green color, plus water. So metal oxides react with acids to form salt and water. So like this we can balance, we can write a balanced chemical equation. It is not given in the textbook, you can write it down. Then so when we saw about metallic oxides reacting with acids. So what happens when non-metallic oxides reacts with base? So carbon monoxide and calcium hydroxide. So in the before reaction we saw carbon dioxide and calcium hydroxide. Calcium hydroxide is a base, reacts with the carbon dioxide, produce salt and water. This is similar to same like base and acid and base reaction. So we can conclude that metallic oxides are basic oxides and non-metallic oxides are acidic in nature. Yes, no? So non-metallic oxides are acidic, that's why we are reacting it with base. And metallic oxides are basic oxides, that's why we are reacting it with acids. So like this we can conclude all the reactions, chemical reactions of the acids and bases. Then when we see acids and bases, what they have in common, what all the acids and bases have in common, we have, so we can confirm it by activity. We have seen that all acids have similar chemical properties. When we see the chemical properties for all the acids, we give generalized chemical properties, like metals react with acids to give hydrogen gas is released, or when it reacts with sodium carbonate, sodium bicarbonate, it will release carbon dioxide gas. It forms salts, and base and acid neutralizes all this. So what is happening here? So why we are giving a generalized reactions, chemical reactions for all the acids? Because they all have common, one thing is common. What is that? Let's see. So take solutions of glucose, alcohol, hydrochloric acid, sulfuric acid, etc. Fix 2 nails on a cork and place the cork in a 100 ml beaker. Connect the nails to 2 terminals of a battery and switch. Now pour some dilute hydrochloric acid in the beaker and switch on the current. Repeat with dilute sulfuric acid, hydrochloric acid, sulfuric acid, like this. Repeat the experiment separately with glucose and alcohol also. So does the bulb glow in all the cases? No, I think. Yes, no. It will glow when hydrochloric acid is there, sulfuric acid is there, but not in the glucose. It can glow in the alcohol also. What is that? Why bulb glows in only in some situations? Why? Because the bulb starts glowing in the case of acids, but you will observe glucose and alcohol solutions do not conduct electricity. So glucose and alcohol will not conduct electricity. That's why bulb do not glow. So glowing of the bulb indicates there is a current flow through the solution. So the electric current passes only when there is ions present in them. So acidic solutions have ions. So acids contain H plus ion as a cation and anions such as Cl minus. In HCl, if we see H plus Cl minus, and when we take nitric acid, H plus and NO3 minus. And when we take sulfuric acid, H plus SO4 2 minus. And when we take acidic acid, H plus and CH3COO minus. Since the cations present are H plus, this common we can see here in all the acids which is present in common, H plus hydrogen ions in the solution, which is responsible for their acidic properties. Then repeat the same activity with the alkalis. Alkalis, what are alkalis? The bases which can dissolve in the solution are called alkalis, like sodium hydroxide, calcium hydroxide. What can you conclude? All these contain a common anion called OH minus. Acids contain H plus. Bases contain OH minus. Okay, so then what happens when acid or base is in a water solution? In a water solution, what happens to an acid or a base? So do acids produce ions only in aqueous solution? Let's see. So take test tube of 1 gram solid. Take about 1 gram solid NaCl in a clean and dry test tube. So sodium chloride in 1 dry test tube. And add some concentrated sulfuric acid to it. Is there a gas coming out of the delivery tube? Yes, test the gas evolved successfully with the dry and wet blue litmus paper. So on the basis of the above activity, you can infer that acidic character of HCl gas or HCl solution. If the climate is very humid, we have to pass the gas produced to the graduated containing calcium chloride to dry the gas. So we are testing here. So whether the reaction occurs only in the solutions or in the dry also. So what happens? This suggests that hydrogen gas ions or hydrogen ions in HCl are produced only in the presence of water. The separation of H plus ions from HCl molecules cannot occur in the absence of water. So what we can say, they can ionize to produce H plus ions in the presence of water only, in the aqueous solutions only. So HCl reacts with water to form H3O plus Cl minus. So hydrogen ions cannot exist alone, but they can exist will combining with water. They combine with water to form H3O plus. So thus hydrogen ions must always be shown as H plus aqueous. We should not just write H plus. We should write H plus aqueous or H3O plus. So because H plus cannot exist independently, it will react with water to form H3O plus. So acids give H3O plus or H plus aqueous ion in water. So when a base is dissolved in water, what happens? Again NaOH in the presence of water, Na plus O plus OH minus. I already told in the bases OH minus ions will be produced. So many examples they gave. So KOH gives K plus OH minus. MgOH twice gives Mg2 plus plus 2OH minus. So bases generally will give OH minus ions in water. So the bases which are soluble in the water are called alkalis. I already told. Bases which are present in water or dissolved in water are called alkalis. So all the bases will dissolve in water? No. So all the bases are not alkalis, but all the alkalis are bases only. So all bases do not dissolve in water. An alkali is a base that dissolves in water. So they are soapy to touch, bitter and corrosive in nature. Don't try to taste or touch them because it is very harmful to us. So we can conclude this. So bases and acids have common what are present in acids. H plus or H3O plus, H plus aqueous or H3O plus ions are present, and bases OH minus ions are present. So when acids or bases react, we already told neutralization takes place and salt and water is formed. What is the reaction here? So when we see HX, that is HCl, like HCl. Acids reacts with bases MOH. This HOH react to form H2O water, and MX is salt. So H plus ions reacts acid. In acids H plus ions are there, and in bases OH minus ions are there. When they both react with each other to form water. So water is a neutral. So when acid reacts with base, it forms water which becomes neutral. Then that is neutralization reactions. Then we can see warning signal displayed on containers containing concentrated acids and bases like this. So let's see what is that. We have to take 10 ml water in a beaker and we have to add a few drops of concentrated sulfuric acid to it and swirl the beaker slowly. Touch the base of the beaker. We can see it is very hot because it is an exothermic process, because the release of heat will be absorbed. We can actually test the base also, like sodium hydroxide pellets, and same observation we can see. So the process of dissolving an acid or a base in a water is a highly exothermic one. So we should take care while mixing acids with water. The acid must always be added slowly to water with constant stirring. When we are adding acid to the water, we have to add very slowly with a continuous stirring. If water is added to concentrated acid, if we do it reverse, then what happens? More heat will be generated and the mixture itself will splash out and all burns will be occurring. So because of more exothermic reaction, excessive local heating. So the glass container itself, the test tube which we are using, it may break out. So that is why the warning sign is written on the concentrated acids and bottle of sodium hydroxide pellets. So mixing of an acid or base with water results in the decrease in the concentration of ions. When we add an acid or base with the water, the H plus H3O plus ions in acid or OH minus ions present in the water will be decreased. Their concentration will be, their number will be decreased. Such process is called dilution. We can say it is diluted. Yes, no, and the acid or the base is said to be diluted. Then how can we say whether acid or base is a strong or weak, or we can tell? So how we can say, we know how acid base indicators can be used to distinguish between acid and base. Already I told how the indicators we can use, whether it is an acid or base to indicate. And we have also learned in the previous section about dilution also, and decrease in the concentration of H plus or OH minus in solutions. We can add water to the acid acid or base in water. Like that we can dilute also. Can we quantitatively find out the amount of ions present in a solution? When we see a solution, we can find out quantity of ions. I told after dilution the number of ions will be decreased. So how much amount of ions are present? How can we find? How can I judge an acid is a strong acid or weak acid? How? So we can do this by using one universal indicator, which is a mixture of several indicators. So the universal indicators show different colors in different concentration of H plus ions. When H plus ions are more, it will have one color. When it is less, it will have one color. So that is the universal indicator. That is nothing but pH scale. That is nothing but pH scale. So a scale for measuring hydrogen ion concentration in a solution is called pH scale. It has been developed. So P in pH stands for potens in German language, which means power. So power of acid or base. So H means hydrogen ion concentration. So on the pH scale we can measure pH generally from 0. Here we can see 0 to 14. So 0 to 7 will be acidic in nature. 7 is neutral and 7 to 14 is basic. So acidic nature increases from 7 to 0, acidic nature increasing. From 7 to 14, basic nature is increasing. So how much less the number is, that much acidic it is. How much big number it is, that much basic it is. Yes, no? Then the pH of neutral solution is 7. Value less than 7 on pH scale is representing acidic. pH value increases from 7 to 14 represents an increase in OH minus. So it is basic. Increase in H plus, increase in OH minus. Generally, paper impregnated with the universal indicator is used for measuring pH. So let's see. So they gave different solutions. How can we find the color of pH paper? So take the pH values of the solutions given and you have to record the observation. When we see here pH solution, we can see gastric juice is 1.2. That means it is more acidic. After that lemon juice 2.2, it is also full acidic. Pure water is neutral, or even blood is also neutral, 7. And milk of magnesia, it is 10, basic. Sodium hydroxide, that is base, that is strong base because it is having last number 14. So the strength of an acids and base depend on the number of H plus or OH minus ions. If we take hydrochloric acid and acetic acid, we take two acids, hydrochloric acid and acetic acid. Which is strong, which is weak? How can you find it? So we took it same concentration, say 1 molar only. Then this produces different amounts of hydrogen ions. So hydrochloric acid will produce more H plus ions. That's why it is a strong acid and it will be less in value. Whereas acetic acid, it produces less H plus ions. Then it is a weak acid. It will be in the middle of this value. So can you now say why weak and strong bases are? So strong acids are having less pH value and produce more H plus ions. Then weak acids are more than 7, from 5 to 7, maybe 4 to 7, and these are having less H plus ions. And strong base refers to more OH minus ions and this area, and weak base will be having less OH minus ions, and it will be from more than 8 or 10, 8, 9, 10, like that. So like this we can judge. Then why we have to use this pH? So what is its importance in our everyday life? We'll see. So all the plants and animals are very pH sensitive. So our body works neutrally. Its range is 7 to 7.8. And living organisms can survive only in this narrow range of pH range. For example, pH of rainwater is 5.6. We can say it is acid rain because it is very less. 7 it should be, but it is less. So It is an acid rain. So when acid rain flows into the rivers, what happens? The river water also will become acid, and all the aquatic life will get will not survive. Yes, no, it will become difficult for their survival. Then if we see the soil, pH of the soil in your ground, backyard, etc. So the specific pH will be there for their healthy growth. If we collect various soils, we can see test the pH also. So what happens? The pH, perfect pH should be there for the plants to grow. So if it is not there, it will not grow. Then pH in our digestive system also. In our digestion system, in the process of digestion of our food, we know that in our stomach hydrochloric acid will be produced. So this it helps in the digestion of food, but it will not harm our stomach also. During indigestion, what happens? The stomach will produce more and more acid, and it will cause us pain and irritation. So to relieve that, what we have to use? Antacid. That is nothing but base. In the beginning of the chapter we discussed this antacid, what it will do, like milk of magnesia. So base 10. So it will, what happens, it will acts as a mild base and often used in this purpose to neutralize the acid in our stomach. Then when pH change as the cause of tooth decay. Tooth decay starts when the pH of the mouth is lower than 5.5. So when the pH is less than 5.5, it is an acid. So what happens? Tooth enamel made up a calcium hydroxypellite. It is the hardest substance. So it will not dissolve in water, but is corroded when the pH of the mouth is below 5.5. When the pH is below 5.5, what happens? So it will corrode our teeth. So bacteria present in the mouth produce acids. Why this acid will be produced in our mouth? Because the bacteria which is present in our mouth will produce these acids by degradation of sugar and food particles remaining in the mouth after eating. That's why after eating we should rinse our mouth to remove this. And the best way is we should clean the mouth after eating food and using toothpaste, which is generally basic, so that it will neutralize our pH in the tooth. Then self-defense by animals and plants through chemical warfare. Have you ever stung by honeybee? When a honeybee stung to us, it will cause us pain and irritation. So because it will leave an acid to us, that is nothing but methanoic acid. So baking soda, if we use baking soda, we'll get a little relief from the pain because it is a base and it will be neutralized. So like this, we can see different uses of pH in our day-to-day life. So when we see some naturally occurring acids like vinegar, what is present in it? Acidic acid. What is the natural source? Is sour milk. Vinegar, acidic acid. Orange, citric acid. Tamarind, tartaric acid. Tomato, oxalic acid. In the sour milk, lactic acid is present. In the lemon, citric acid. Ant sting, when ant bites, what is present in that? Methanoic acid. It will release methanoic acid. Nettle sting, it will also produce methanoic acid. Nettle is a plant which grows in a wild. It has stinging hair-like structures. When we touch it accidentally, we'll get painful stings. So the remedy for this is rubbing the leaf of the dock plant. So which will be available next to do that only. It is basic in nature and it will help us to remove the pain. Then up to now we discussed about acids and base. Now we will discuss about salts. So we have seen in the from the formation of salts, from metals react with acids or acid bases react with each other to form salts. So we'll see their properties and uses now. So we'll see a family of salts. So we see the chemical formula of the given salts. Potassium sulfate, sodium sulfate, calcium sulfate, magnesium sulfate, copper sulfate, sodium chloride, sodium nitrate, sodium carbonate and ammonium chloride. So when we see here, potassium sulfate or sodium sulfate, calcium sulfate, magnesium sulfate, copper sulfate, all have sulfate in common. They are sulfate families. Yes, no. Then sodium chloride, sodium nitrate, sodium carbonate. These are sodium families. Yes, no. Or sodium chloride, ammonium chloride, chloride family. Yes, no. We can see the acids and bases from which they are formed also. like potassium sulfate, maybe sulfuric acid and potassium hydroxide, and sodium sulfate may be sodium hydroxide and sulfuric acid, calcium hydroxide and sulfuric acid, magnesium hydroxide and sulfuric acid, copper hydroxide sulfuric acid, sodium hydroxide hydrogen chloride, sodium hydroxide and nitric acid, sodium carbonate or sodium hydroxide and sodium hydroxide and sodium carbonate, like this, or ammonium chloride, maybe sodium then. So salts may have some positive or negative radicals are said to be belong to the family. For example, NaCl and Na2SO4 belong to sodium salts. Similarly, NaCl and KCl belong to chloride salts. So what are the pH of the salts? So actually when we think of salts, we can say they are neutral. Yes, no? So collect the following samples: sodium chloride, potassium nitrate, aluminum chloride, zinc sulfate, copper sulfate, sodium acetate, sodium carbonate, sodium hydrogen carbonate, and whatever are the salts which are available to us. Just do the solubility test by dissolving it in water, and we can test it whether by acid or base by using litmus and find the pH. Then we can see some salts are acidic, some salts are basic, not correctly neutral. How this happens? Let's see. So when we prepare a salt by using a strong acid and a strong base, both are strong, then we'll get correctly neutral pH of value of 7. On the other hand, when we use salts of strong acid and a weak base, then the pH value, because of strong acid, more H plus ions, then the salt which is formed is acidic and have less than 7 pH value. And when we prepare strong base and weak acid and strong base, then because of more OH minus ions, strong base is present, so basic in nature. The salt is basic in nature and pH will be more than 7. Like this, we can find out the pH of the salt. Then chemicals from common salt. What is common salt? Sodium chloride, right? So the salt formed by the combination of hydrochloric acid and sodium hydroxide is sodium chloride. Yes, no? Hydrochloric acid and sodium hydroxide, which we use in our daily life. In our food, what we use the salt is nothing but common salt is sodium chloride. So seawater contains many salts dissolved in it. Sodium chloride is separated from these salts, and deposits of these solid salts are are present in several parts of the world. These large crystals are often brown in color. So what we are using will be white. Yes, no. Before that it will be brown in color because of some impurities, and this is called rock salt. So beds of rock salt were formed when seas of bygone ages dried up. So after so many years, when the seas are dried up, these salts will be found. So even like how the coal is mined, we can dig the rock salt. You must have heard about Mahatma Gandhi's Dandi March also. You know that sodium chloride is that much important in our freedom struggle also. Yes, no? Then, so this common salt is very useful not only in our food to cook, but also it is an important raw material for our daily use, such as we can prepare sodium hydroxide, baking soda, washing soda, bleaching powder, and so many compounds from this. So let's see how we can prepare from this common salt this many compounds. When we see first one, what I told, sodium hydroxide. So sodium hydroxide, when electricity is passed to the aqueous solution of sodium chloride called, when we have to prepare an aqueous solution of sodium chloride powder should be dissolved in water to form sodium chloride solution. It is called Brain solution. So it decomposes to form sodium hydroxide, and this process is called chlor-alkali process. So what is this chlor-alkali process? Because the products obtained are, chlor means chlorine is formed and alkali is sodium hydroxide process. So NaCl, when we make it aqueous by dissolving it water, and when a current is passed, it forms sodium hydroxide plus chlorine plus hydrogen. So here sodium hydroxide is produced. Chlorine gas is given off at the anode. So chlorine gas is given off at anode, hydrogen gas at the cathode. Sodium hydroxide solution is formed near the cathode, and so the products obtained all are useful here. No, nothing is waste in this, because chlorine is used in the bleaching powder. Yes, no. So let's see. So you have come across the chlorine is produced during the electrolysis. We saw that chlorine is produced in this electrolysis process. This is used in the manufacture of bleaching powder. So bleaching powder is produced by the action of chlorine on dry slaked lime. So dry slaked lime is calcium hydroxide. When we take and react with chlorine, we will get CaOCl2. That is nothing but bleaching powder. So what is the chemical formula of bleaching powder? Calcium oxychloride, CaOCl2. Yes, no. Though the actual composition is quite complex, they gave like this. Yes, no. Then, so what is the uses of its bleaching powder? We already know bleaching powder is used in textile industries and wood and pulp in paper factories, and also for bleaching the clothes. Even it is used as an oxidizing agent in many chemical industries. Even in water, to kill the germs, this bleaching powder is added. Then next is we can see baking powder or baking soda, how it is prepared. So baking soda is commonly used in our kitchen. So when we put some dosa, idli or something, we will add some powder, that is nothing but baking soda, or even in the cake formation, cake. It's no, sometimes it is used to add for faster cooking also. The chemical name of the compound is baking soda is sodium bicarbonate or sodium hydrogen carbonate. So it is also produced from again salt, sodium chloride plus water plus carbon dioxide plus NH3. It will give ammonium chloride and sodium bicarbonate. When we check the pH of sodium hydrogen carbonate, can you correlate why it can be used to neutralize an acid? Because it is a base. So it is a non-corrosive basic salt. It is a basic salt. So following reaction, we already told baking soda should be used. So for acidity, yes, no, because it is a base. So sodium bicarbonate, when we heat it again, it will become sodium carbonate, water and carbon dioxide is produced. So it has got various uses in our household. So for making baking powder, so baking soda is used, which is a mixture of baking soda and a mild edible acid such as tartaric acid. When we mix it, it will become baking soda. When it is heated or mixed in water, what happens? Sodium bicarbonate with H plus ions reacts in the acid. From the acid H plus ions, it will form CO2, H2O and sodium salt of acid. So this carbon dioxide produced in this reaction will cause the bread or cake to rise. So we can see small holes present in the cake or bread when we bake it, and because of the carbon dioxide produced, and it will make soft and spongy. Then sodium hydrogen carbonate is also an ingredient in antacids also. It is also used in antacids. When we get more excess acid in the stomach, it will give relief. And even it is used in soda acid fire extinguishers. Why we are using it in fire extinguishers? Because CO2 is produced, which is a extinguisher, fire extinguisher. Then it is also used in washing soda. So what washing soda is? Sodium carbonate 10H2O. You can observe that sodium carbonate can be obtained by heating baking soda. When we heat baking soda, we will get sodium carbonate, it gives washing soda. It is also a basic salt. So sodium carbonate, we can see here 10H2O is there. What is that 10H2O? Washing soda, I told Na2CO3, 10H2O. What is the 10H2O means? So is it important? Yes, it makes Na2CO3 wet. So we'll see sodium carbonate and sodium hydrogen carbonate are useful chemicals for many industrial process also. Yes, sodium carbonate 10H2O is necessary, and it will not make the substance wet, but it will be hidden inside. So sodium, what are its uses? When we see, it is used in glass, soap and paper industries. It is also used in the manufacture of borax, and also used as cleaning agent for domestic purpose, because of washing cleaning agent, and it is also used for removal of permanent hardness of water. Then when we take copper sulfate crystals, which seems to dry, contain water of crystallization. So we see the copper sulfate crystals. It appears like it is dry, but it have some water inside it. This can be removed by heating it. When we heat it, the salts will turn into white. Actually, it will be blue color, no? Copper sulfate crystals. When we heat it, it will become white by removing of water in that. If you moisten the crystals again, you will get again the blue color. So, water of crystallization is a fixed number of molecules, water molecules present in one uniform formula unit of salt. So 5 water molecules are present in copper sulfate. That is why in washing soda also 10 water molecules. In copper sulfate 5 water molecules is present. Now you understood why washing soda Na2CO3 10H2O is not wet. It appears dry but it has water molecules inside. So like this of water of crystallization is present is one more salt is nothing but plaster of Paris. So on heating the gypsum at 373 Kelvin, it loses water molecules and become calcium sulfate hemihydrate, CaSO for half H2O, and this is called plaster of Paris, which the doctors will use this for supporting fractured bones in the right position, and it is a white powder, and when we mix it with water it again changes to gypsum and will give hot solid mass. So CaSO for half H2O, when we react it with water it will become CaSO for 2H2O, which is gypsum. Now you will be wondering what is this half H2O, why we are adding with 1.5 H2O, what is this? See here, half H2O of molecule is shown to be attached as water of crystallization. How can you get a half a water molecule? No, it is not possible, because 2 formula units of CaSO4 share 1 molecule of water. So 2 CaSO4 molecules will share 1 water molecule. That's why to write singly we wrote like this. Half H2O will not exist, right? So plaster of Paris is also used for making toys, decorative products, and making surfaces also smooth. So why is calcium sulfate hemihydrate is called plaster of Paris? So why it is called plaster of Paris? Answer me, comment me in that. And our lesson is also completed. Thank you. Let's see with the next lesson.